Limiting reactant. The poisonous gas hydrogen cyanide, HCN, is produced by the high temperature reaction of ammonia, NH3, with methane, CH4. Hydrogen is also produced in this reaction. So write a balanced chemical equation for the reaction that occurs. And then in part B, suppose that 500 grams of methane is mixed with 200 grams of ammonia. Calculate the masses of the substances present after the reaction is allowed to proceed to completion. So for part A, all we have to do is write a balanced chemical equation for the reaction. So let's reread the problem statement. The poisonous gas, hydrogen cyanide, is produced by the high temperature reaction of between ammonia and methane. Hydrogen is also produced. So we know the reaction is between ammonia and methane. So those are our two reactants. And the product is the gas HCN and hydrogen. So we'll write this out. So ammonia, NH3, plus methane, CH4, becomes, when reacting, HCN, which is a gas, plus H2. So let's check to make sure it's balanced. It's not. So what do we need to do to balance this? We have 1N, that's good. 1C, that's good. So total we have 7 hydrogens, whereas here we only have 3. So we need a coefficient of 3 to get 7. And now we're balanced. Suppose 500 grams of methane is mixed with 200 grams of ammonia. Calculate the masses of the substances present after the reaction is allowed to proceed to completion. So what we're going to do here is convert each of these masses of reactant and convert it into moles of these reactants. Then the moles we will convert into moles of product, one of the products, and using the coefficients in the chemical reaction, we can determine which will be the limiting reactant in the reaction, and thus we'll be able to calculate the masses of the products and the excess reactant in the end. So we'll start off with 500 grams CH4, and we'll convert this into moles, CH4. So grams CH4, and then moles CH4. So 1 mole of CH4, 16.0425 grams. And then 1 mole of CH4 becomes, or is able to produce, based on the coefficients, 1 mole of HCN. So where we got these values is from the coefficients in the equation. So it doesn't matter which product you put here, as long as you do it do the same product with the same coefficients now and in the second stoichiometric process that we're going to do when we have 200 grams of NH3. We're not doing that yet, but when we do it, we will also use 1 mole of HCN, one coming from here. So this gives us 31.167 moles of NH3. Moles of HCN. So 200 grams of NH3. So grams of NH3 into moles of NH3. So 1 mole of NH3, 17.0305 grams. So for 1 mole of NH3, 1 mole of HCN is also produced. This gives us 11.744 moles of HCN. So much more HCN forms when 500 grams of CH4 reacts to produce it than 200 grams of NH3. As such, NH3 is the limiting reactant in the reaction. So at the conclusion of the reaction, there will be none of the NH3 remaining because it's the limiting reactant, so it's completely used up. Some CH4 as an excess reactant, and then HCN and H2 as products. Though they will remain as well. So now that we know how much is produced, how much HCN is produced from the limiting reactant, we can save this value and continue on with the process. So I'm going to erase everything here. So we have 11.744 moles of HCN. Now, we're going to convert this into moles of CH4 and then into grams of CH4. So moles of HCN, 1 mole of HCN is produced for 1 mole of CH4 reacted. And 1 mole of CH4 is 16.0425 grams. This gives us 188.4 grams of CH4 used. So we started out with 500 grams CH4. We used 188.4 grams CH4, and we're left with 311.6 grams CH4 in excess. So let's convert 11.744 moles of HCN into the other products, or into the products. So the reason we're able to use HCN as this beginning factor is because we know it's the absolute maximum amount of the product of HCN that can be produced due to the limitations of 200 grams of NH3. So we could use moles of NH3 here, but it's easier to simply use one of the products because we need to convert the HCN into grams anyway. So that's why we're using moles of HCN rather than moles of NH3. So now we'll convert this into simply grams. So 1 mole of HCN is 27.0253 grams. So 317.4 grams of HCN is produced. .744 moles of HCN, converting that into moles of H2. So So 1 mole of HCN is 3, or produces, it is produced when 3 moles of H2 is produced. 1 mole of H2 is 2.0159 grams of H2, giving us 71.02 grams of H2. The way we found this value for 3 moles of H2 for 1 mole of HCN is from the coefficient of the chemical reaction above, which shows that for every 1 mole of HCN produced, 3 moles of H2 are produced at the same time.